Hello dear students, welcome back. Today we are going to take up a new chapter, chapter number 10, and the name of the chapter is Motion and the Measurement of Distance. In this topic, we are going to see what is this motion, what are the different types of motions, and how can we measure the length of certain objects. So first, let us start with the topic measurement. Measurement, it is the comparison of the length of an unknown object with something whose length is known. The measurement is done by comparing the length of certain objects. In order to know the accurate length of an object, the measurement is done by the help of a measuring scale. In the ancient time, the length of the objects are measured in different ways, like the length of our palm, like the length of our hand's palm. So, in this way, the ancient peoples used to measure the length of certain object. But this type of measurement is not reliable, as the palm length or the hand's palm, they are not equal for different people. Because of that, there is a need for having a measuring scale or a measuring device. So now let us learn how can we measure the length accurately. Suppose we think of measuring the length of this object. I have drawn a rectangle to represent an object. In order to measure this length of this object, we can use a measuring scale. A measuring scale used to have different markings on it. Some of the markings are long while some are short. This long marking represents a centimeter marking. The one end of this scale will be marked 0. The second one will be marked as 1. The distance between this long marking, two long marking, it is 1 centimeter. In between these two long marking, there are 10 small markings. This small marking, the length of one small marking, it is 1 millimeter. So, in order to measure the length of an object, we have to put the long marking, the 0 marking at one end of the object. On the other end, the marking which coincides with the other end of this object will be the length of this object. Let us say, for example, at the end, the other end of this object lies on the marking of 10 centimeter. Then, the length of this object is 10 centimeter. Understood? Okay. Here, the length of certain object is measured in terms of different units. Some of the units for measuring the length are kilometer represented by km, meter represented by small letter m, centimeter represented by small letter cm, and millimeter. These are some of the units that we use for measuring the length of an object. Now, let us see how these lengths are interrelated to one another. 1 kilometer is equals to 1000 meter. 1 meter is equals to 100 centimeter, and 1 centimeter is equals to 1 millimeter. So, in this way, we can convert one unit into another unit if we know these values. During measurement, we have to take up certain precautions so that the measurement or the reading that we got is an accurate length of that object. When we try to take the measurement, we should take the measurement by keeping the scale parallel to this object. Let us say this is the scale, this is the object. The scale should be kept parallel to this object, and after that we have to coincide the 0 marking of the scale with one end of the object, and the other end, the marking of the scale which falls on this another end of the object will be the length of that object. Sometimes, if we are using a scale, broken scale, in which the 0 marking is not there, then we have to take the full marking of the scale coinciding with one end of the object. Let us say the scale. The first long marking is the mark of 2 centimeter, is on the mark of 2 centimeter. then we have to keep this 2 centimeter marking on one end of this object. Then the other end, let us say here 10 marking, 10 centimeter marking, it falls on the another end of this object. Then we have to measure the length from this 2 to 10. So the correct measurement, correct length of this object will be given by the final marking, that is 10 centimeter, minus the initial marking that we have taken, that is 2 centimeter. So the length of this object will be equals to 8 centimeter. So in this way we have to measure. And while recording the length of this object, the position of the eye should be exactly vertically up on this marking. We should not look it from the sideways. It should be vertically up from the above the scale marking. So these are the precautions that we have to take while recording the length of the object. Now this is about the measurement. Now let us come to the next topic of this chapter, that is motion. Motion is the state of an object. When an object is changing its position with respect to time and surrounding, then we used to say that the object is in motion. In short, motion actually means the change in the position. Motion is related to one another term which we call it as a rest. When an object doesn't change its position with respect to time and surrounding, means it is remaining at the same position. At the time we used to say that the object is at rest. This motion and rest, they are related to one another because the motion of an object, whether an object is in motion or not, is moving or not, we used to find it out by comparing its position with another object that is present in the surrounding which are at rest. So this motion and rest, they are related terms. Motions are of different types. Let us see these different types of motions and let us try to know what are these types. There are 8 types of motion. The first one is known as the translatory motion. Translatory motions are the type of motions in which the object used to change its positions in some duration of time. The translatory motion is again divided into rectilinear motion and curvilinear motion. Rectilinear motion is the one in which an object used to move in a straight line, while curvilinear motion is the type of motion in which the object used to move in a curved manner. Next type is known as the circulatory motion. An object is said to be in a circulatory motion if it is moving in a circular path. When the object moves in a circular path, we call it as the circulatory motion. For example, the movement of the planet around the sun. The planets used to move in a circular path or in a circular orbit. So, the movement of the planet can be said as a circulatory motion. Next one is known as the oscillatory motion. Oscillatory motion is the type of motion in which the object used to move to and fro. If it is moving up and down in this way, we can call it as a oscillatory motion. The movement of the pendulum of the clock is an oscillatory motion. Next one is vibratory motion. The vibratory motion is the one in which an object vibrates. Here, there will be no change in the position of the object, but there will be change in the structure and the shape of the object. Next one is the periodic motion. If the event occurs again and again, we call it as, at a particular interval of time, taking the same time, we call it as a periodic motion. The occurrence of day and night, it used to occur in a particular interval of time and it used to repeat again and again every day. Such type of motion we call it as a periodic motion. Non-periodic motion is the one in which the motion used to occur continuously but at taking different interval of time. Going from home to school and from school to home, sometimes it used to happen every day. But the time interval that used to take when we go from school to home and home to school, it may be different. Such type of motion we call it as a non-periodic motion. Next one is uniform motion. It is the type of motion in which an object travels equal distance in equal interval of time. Let us say, for example, an object which is moving covers 1 kilometer in the first 1 hour, another 1 kilometer in the next 1 hour, another 1 kilometer in the next 1 hour, and another 1 kilometer in the next 1 hour. So here, this object is covering equal distance in equal interval of time. Such type of motion we call it as a uniform motion. The last type of motion is known as the non-uniform motion. It is the type of motion in which an object covers unequal distance in equal interval of time. Let us say an object is moving. It covers 1 kilometer in the first 1 hour, 2 kilometer in the next 1 hour, 5 kilometer in the next 1 hour, and 1 kilometer in the next 1 hour. So here, in every interval of time, the distance that is covered by this object are different. Such type of motion are known as non-uniform motion. So these are the things that we studied in this chapter and in this today's class. So for today, we are going to wind up here. In the next video class, we will take up a new chapter. So for today, let's stop here. Thank you.